Page 11 video for the mat050 final review sheet study guide for the final. Question 27 on page 11. Once planted, small maple trees typically grow 2.5 feet each year. So I know from 2 to 4, that's 2 years. 2.5 feet each year, that's actually going to be 5 feet that it grows. And 4 to 6 is another 2 years, so that's 5 feet. So 2 years, it's 7 feet. 4 years, it would be 12 feet. And 6 years, it would be another 12 feet. So I can fill in the table really quickly. Another question we might want to think about, come up later, but I can also calculate 0 years. After being planted, I'll just take away 5, and so I'll get 2. That's going to be important later, but right now, find the slope of the line and explain what it means. So years is x, height is feet. What I need to know to find slope is how many feet it grows in 1 year. So if x changes by 1, how much does y change by? And if x changes by 1 year, the height changes by 2.5. So 2.5 feet per year. And that's basically when you explain what it means that the tree grows 2.5 feet each year. Okay. Find the y-intercept and explain what it means. Y-intercept I just showed you was 2, so y-intercept equals 2 feet. And it means that when the tree is first planted, it's 2 feet tall. It begins to grow from there. Question D, write an equation of the line. Once again, y equals slope times x plus the y-intercept, or y equals mx plus b. I'm going to plug in the numbers now. 2.5 x plus 2. Restate your equation in the form of a sentence. I don't want you to sit there and watch me write that. I'll just read it to you. If x represents the number of years after the maple tree is planted, then y equals 2.5x plus 2 represents the height of the maple tree after x years. Okay. So if you want to pause and try to write that down, that's fine. The important thing is you understand what I said. And question F, use your equation to find when the tree will be 37 feet tall. Okay. And so come over here. I'll go back to that equation, y equals 2.5x plus 2. And I'm going to put in what I know. Y is 37. Y represents the height. We want the height to be 37. So instead of saying y equals 2.5 x plus 2, I now know that 37 equals 2.5 x plus 2. Now I just need to solve an equation. I'm going to subtract 2 from both sides. I get 35 equals 2.5 x. X is a number that I multiply by 2.5 to get 35. I'm going to divide that by 2.5 to see what x is. And since it's an equation, I can divide both sides 2.5. So I get x equals 35 divided by 2.5. And I come back over here and say x equals 14 years. Because x is the number of years. And to check my answer, 2.5 times 14. 2 times 14 is 28, plus 7, 35. And then I add 2, I do get 37. Pause the video a moment and see if you can answer question 8. Then come back, check your answer. Okay, question 8. Now that you've looked at it, use the area model. And remember, our book calls that the Punnett squares, but it's really an area model. That has nothing to do with math. Forget that term. Use the term area model to find the factored form of the following expressions. Be sure to label the outside of the area model and the inside. The area model is typically, we use that because we want to represent two polynomials that are multiplied together by the sides of the rectangle. And then we multiply them to get the area inside. Here, I don't know what goes on the outside. And I have some clues as to what goes on the inside. I know I have x times x. Because I have to get x squared somehow. I can only do that by doing x times x. So I've got that to start with. And I know when I multiply the two numbers, I'm going to get negative 18. I also know, once I know these two numbers, I'm going to add those together because they're like terms. So I need to multiply to get negative 18. I need to add to get positive 7. So I know one of them is going to be negative and one of them is going to be positive because that's the only way I can get a negative 18. So I'm going to put a negative up here. I'm going to put a plus down here. So now I have to look at 18. I could do 1 times 18, negative 1 times 18, or I could do negative 18 times 1. Well, think for a minute though, if I do negative 18 times 1, I would add negative 18 and 1, I would get a negative number. Since I want a positive number here, when I add them I want to get a positive 7. I know that the bigger number has to be positive. So I don't want to try negative 18 and 1. I try negative 1 and 18. When I add those together, I get a positive 17. So that's not going to work. Let me try 2 and 9. There again, I want the larger number to be positive, so I would try negative 2 and positive 9. And if I add those two together, 9x plus negative 2x is going to give me 7x. So that's the one I want. So I do minus 2 and 8. Minus 2 and 9. So my answer is, first of all, check it, 9x, because I do 9 times x, and then x times negative 2, I get negative 2x. Add those together, I do get positive 7. So I can say my factored form is x minus 2 times x plus 9. You could have written x plus 9 times x minus 2. It's the same thing. I'll go through the same process on b. So I have x squared. I know one of my squares has to be x squared. And I know when I multiply my two numbers together, I get negative 45. So that tells me I got an x here and an x here. And the other clue I have, when I add these two numbers, I have to get negative 4x. So this time, once again, I have a negative 45, so I know I have to multiply a negative times a positive. When I add them, though, I get negative 4. That tells me that the negative number has to be bigger. So if I look at the things I can do, I could do 1 times negative 45. I could not do negative 1 times 45 because that would give me a positive value. I need a negative value. But adding 45 and negative 1 does not give me 4. It gives me 44. So I'm going to try 9 and 5 gives me 45. I want the bigger one to be negative, so I'm going to do negative 9 and positive 5. So that gives me 5x and negative 9x. When I add those together, negative 9 plus 5 does give me 4. So I know that's the one I want. I'm going to put x minus 9 times x plus 5. That's all for this video. Go ahead and work on page 12. See if you have questions, you can watch the page 12 video.